In today's ChemTalk, we will discuss about the concept of matter and atom. The highlights are as: what is matter? States of matter. Composition of matter. Changing states. Historical and scientific context. Classical states of matter. Exotic states. Phase transition and state changes. Modern research. Implications and applications. Conclusion. Matter is anything that has mass and occupies space. It is composed of tiny building blocks called atoms, which can combine to form molecules. This forms the basis of everything we see around us, from the air we breathe to the ground we walk on. There are four fundamental states of matter commonly observed: solid, liquid, gas, plasma. Each state has distinct properties. Solid has a fixed shape and volume, like ice or a rock. Liquid has a fixed volume but takes the shape of its container, like water or juice. Gas expands to fill its container, like air or oxygen. Plasma, found in stars and lightning, it's a gas with charged particles, making it conductive. Matter is defined as anything that has mass and occupies space, encompassing all physical substances in the universe. It is composed of atoms, the basic units of matter, which consist of protons, neutrons, and electrons. Atoms can combine to form molecules held together by chemical bonds, forming the basis of all materials. For instance, water molecules HO consist of 2 hydrogen atoms and 1 oxygen atom, illustrating how matter's building blocks create diverse substances. Since the matter can transform between states through phase changes, such as melting solid to liquid, freezing liquid to solid, and vaporization liquid to gas. These changes are driven by adding or removing energy like heat and are influenced by temperature and pressure. For example, ice melts into water when heated and water boils into steam. The concept of matter has evolved over centuries, with ancient Greek philosophers like Democritus coined the term atomos. Atomos is derived from the Greek words a meaning not and temnao meaning to cut, designating it as indivisible particle. However, later on John Dalton in .1803 provided a scientific basis, picturing atoms as solid spheres. In his experiments and modern science, refining this through experiments such as John Dalton's atomic theory in 1803. This concept was refined by J.J. Thomson, Ernest Rutherford, and Niels Bohr in their models, revealing electrons, nuclei, and quantum behaviors of atoms, showed that atoms are not indivisible but contain quarks and gluons. Today, we understand atoms are not truly indivisible, containing subatomic particles like quarks, but for most practical purposes, atoms remain the fundamental units. In upcoming ChemTalk, we will discuss classical states of matter, exotic states, phase transition and state changes, modern research, implications and applications. Conclusion. Was this helpful? Like, subscribe, comment, and recommend me for more such talks.